thank you so much for joining us for today's session for Zilliz Cloud January 2024 product launch, delivering the most performant vector search with Zilliz Cloud. I still need to cover a few housekeeping items, and then we'll get right into the session. So firstly, the webinar is being recorded. So if you have to drop off at any point, you will get the access to the on-demand version within a few days. If you have any questions, I think someone already did to mention that they cannot hear, but feel free to just paste them into the Q&A tools at the bottom of the screen. So before we get into the features, I really want to just talk about what Zilliz Cloud is. So firstly, it's really based on the most widely adopted open source vector database, Milvus. We still invest like lots of engineering resources to keep making Milvus better. Then the stable Milvus version will continue to deploy to Zilliz Cloud. So that becomes the core of the Zilliz Cloud. But on top of that, we actually try to really just re-engineer and optimize Milvus. So you're going to get a better performance and a lower TCO versus to Milvus. The other thing we really try to do is really go above and beyond the Milvus and just try to build a few essential enterprise features, which including both more flexible deployment and also security feature to create this production-ready platform. Another really important thing is we want to build the unstructured data platform and just help you to connect and transform data. So we built a few features, including pipelines, which is public preview right now, and more connectors and integration. We're going to talk about that later as well. So basically, we want to build this kind of platform that is well integrated into the data and AI ecosystem. Now let's get right into this very exciting launch highlights. So that's the pillar I mentioned earlier. Let's start with the optimized Milvus. So the key highlight of this launch is the Cardinal. Cardinal is a highly efficient vector search engine. So it's designed for our fast approximate nearest neighbor search, what we call ANNS. It can handle a wide range of tasks and support various data formats. Cardinal focused on speed and efficiency, allowing more user requests with resource limits. It's optimized for both x86 and ARM hardware. Cardinal offers a 10 times performance boost over open source Milvus. This makes vector search quick and more efficient, enhance AI application and user experience. Another key highlight of this launch is after a few months beta, the much anticipated Milvus 2.3 is generally available on Zilliz Cloud. So I listed a few highlights here. The number one is cosine metrics. So it's advanced similarity metrics, especially popular among NLP. Cosine eliminates the need for prior vector normalization. So if developer want to conduct cosine calculation, right now it's easier. Then the second really important feature is range search. Personally, I really like this feature. James will talk a bit more later about this one. So this feature actually provides a more precise data retrieval method for some specific use cases. It broadens the scope of vector querying beyond top K search. It's potentially beneficial for recommendation engine, ensure more relevant suggestion for users. Another really key feature is Upsert. Upsert simplifies data management in updating and delete data sets. It's particularly valuable in dynamic environments where data consistency and atomicity are crucial. Then let's move to the production-ready pillar. A really key, the engineering team actually spent like quite a few months to really build the more granular role-based access control. So with our robust access control, we actually provide your like a for cluster and a project role. So that's like a for operational permission, like you can manage your projects and billings. Then the even more important thing is we also provide the data layer permission. So for example, you want to add or view certain data. For the data layer, we have free built-in one customer role. So basically just really help you and enhance security and teamwork while ensuring the user have the right access to the right job. Then another really exciting announcement we want to talk about here is we're available on GCP Marketplace. And the even better news is that if you are signed up through GCP Marketplace, you are going to receive an extra $100 credit on top of the standard $100 credit available to all new users. Okay, so the last pillar is about streamline our unstructured data. We're really excited after like a tremendous positive feedback we heard from the Confluent and Airbyte connectors we launched last year. Right now, we're introducing the Databricks and Slack connectors for easy data migration and transformation. It supports both streaming and batch data imports into Zilliz Cloud and help team and individual with tasks, those updating models or uploading data. Okay, now I'm really pleased to introduce James, our VP of Engineering, for the deep dive of this new features. James, welcome. First and foremost, I really want to talk about Milvus. So for Milvus 2.3, it's been quite a few months since we released it to the Milvus community, to the Zilliz Cloud. Can you talk about why we don't have the feature parity over there between Milvus and Zilliz?
Yeah. First of all, we are like very conservative about publish any new features to Zilliz Cloud. The reason is we want to keep our Zilliz Cloud very stable and also compatible with all the previous features. And many of the newest features released in beta, so we want the users to open source users to try all those features and provide us more feedbacks. So those features are probably in very early stage. So we might do some adjustments on both the interface and also the restrictions. But on the other side, we hope that Zilliz Cloud can users can use more stable features and interfaces. So because we believe that compatible is going to be very crucial for all the users in production. So that is our key goal, to keep around 3 to 6 months delay compared to our open source Milvus. Yeah. This means that for all the cloud users, you might need a little bit patient with the new features. In fact, we're just going to go in to release Milvus 2.4 soon this month, including some more exciting features like multi-embedding support, like scalar inverter index, like sparse embeddings. And those features are going to be in this cloud maybe middle of this year. So also, I think one of the reasons we don't do more restriction to SaaS is because this not only ensures accessibility, but also guides the users who want to use this product in the right way. For example, we limit the number of collections created on this cloud because we find that a lot of users who want to build their RAG applications, what they usually try to do is building hundreds of thousands of the collections, each collection for one tenant. Yeah, but this put significant load on the cluster. So in fact, if you want to build multi-tenant applications, the recommended way to do that is using a feature called partition key, where you can just support millions of tenants in one collection. And when you do search, you can like filter out the tenants you want real quick, and that gives much better performance as well as less a burden on the system.
Great, that's really great tips. If you have any questions regarding how to use Zilliz Cloud, please do not hesitate to reach out to us. Our support team, we're definitely very happy to help you. Then let's talk a little bit more about the Milvus 2.3. As I mentioned, one feature I found super interesting is range search. Not every vendor actually has this kind of feature. Can you just tell us a little bit more about range search and what some of the use cases best for, and maybe show us a little demo about how people can actually leverage it like a power?
Sure. So just said that your favorite feature into what's is range search. Mine is not. I would prefer for Upsert because I mean a lot of users also like expect for Upsert. Yeah, but for range search, I mean most of the vector database, right? For now, what we do is called AN, approximate nearest neighbor search. And usually what we do is perform a top key queries. So when you give a query vector embedding, and the database will return you top key most similar nearest neighbors. However, in many of the use cases, we don't know like what exactly number of key we are looking for, but we just want to retrieve all the data in certain distance range. This need is particularly common in anomaly detection, in some of the image reverse image search. So moreover, unlike the top key mode, the volume of data you want to retrieve from certain region might be very large. If I said I want to retrieve all the vectors which have distance between 0.5 to 1 on a cosine matrix, right? I might got a very large number of entities. Yeah, so it might exceed the limits of a single RPC can handle. So in such case, range search can be used together with iterator features. So you can just iterate all the data one by one, make sure that it won't break the RPC limit, as well as it won't break your memory. So through our testing, with the iterator, you can scan 10,760 dimensional data with less than 10 minutes. So you can also use this feature to export all the data all of the cluster. So that is going to be really useful for most of the vector database. Once you put in all your embeddings, you get vendor locking. There's no way that you can pull off your vector embeddings out. And with range search and also iterators, it definitely helps you. So what I will do next is I will give a quick demo about our range search. So let's start. So I actually have built a quick demo. So in this demo, I have a bunch of data. I have a min.py, which is a Python file that I will execute each step. So the first thing I will do is let's quickly see what kind of data set I got. Okay, so actually I have 10K data, and with PK field from 0 to 10K, with some descriptions, with width and height, which is integer numbers, and also for sure there's full 32 vectors. So I also start Milvus cluster in the backend. So okay. So the first step I will do is to run a preparation collection. So what we do in this demo is we connect to Milvus, we create a collection, then we create a collection named demo SNTT. We insert 10K entities into this cluster, and then next step, what I will do is a traditional search or just a top key search. Oops. Oh, I need to change the name. All right. So let's see what we got. So on the top, I got the most similar result with a distance 0.9.9, which means it's almost the same entities, right? And if you go through it, you get some other IDs. For this one, you got a cosine matrix similarity to be 0.8, which is also very similar. And in this demo, I got around 100 results. So if we take a look at what we did in this search demo. So what we did is we connect, we create a collection, we do a search. In the search, we have a limitation of 100. We also specify a bunch of output fields. Yeah, we use a cosine matrix. Yeah, and we also at the end we print out the recall, right? So let's see what recall get. Oh, great. So the recall is 1.0. So everything is great. So that is for traditional search. So what will happen for range search? Let's run the other test. I have my collection name as so we still get recall to be 1.0. And if you take a look at this, I'm trying to search between range from 0.75 to 1.0. No surprise, you still get most similar result with ID equals to 0, right? And the similarity is the same as what we do as top key. And if you scroll down, then you will see that you get a lot of other IDs. And for the last result, right, the distance is around 0.75. That is the range I specified. If you take a look, if you take out the code, so there is a slight difference. So when we do search, instead of specify top K, we also specify a range, which is in the params, right? We said the radius equals to 0.75, which means the least likely the least likely data should have a similarity more than 0.75. So that is what we call it a range search. Yeah. And range search can be also used together with filterings. So under that case, what we can do is we can do a filtering search where we can have another condition with equals smaller than 500. If you take a look at the last result, right, you will find some widths larger than 500,000. 500. For example, if you look at this one, you definitely see that the width is 578, right? But what will happen if you run a filtering search with range together? Then you'll see the result is much lesser than without the filtering, right? And if you take a deep look into all the result, you'll see that all the width is actually less than 500. So, and the most amazing part for the range search is you can work, it can be used together with the iterator. So let's say when I run this demo and they give me the first 10 results, I skipped 8 of them. The top, most likely one is still you get the 0.99 similarity, and the top 10 you get 0.75, right? And you can still continue, and the 11th is actually a slightly further than the 10th, and you get another 10 result, and if you keep going, you get another 10, and you keep going. Okay, so you get all the results. So with these iterative features, you can get a very large data set without worrying about your claim to get OM or RPC limitations. Yeah.
Great, that sounds very exciting. Then let's talk a little bit, switch the gears to talk a little bit about the Cardinal. So for Cardinal specifically, I would love to hear the story behind. We already got nowhere for Milvus. What made the engineering team thinking, hey, we need to build another new search engine just specific for Zilliz?
Yeah, the initial idea behind constructing Cardinal is to achieve a unified vector index, because in Milvus, at Steffi said, we have a library called Nowhere, where we try to integrate all of the SOTA vector search libraries like FAST, HW, DSKN, to align all functionalities with this vector index. We did a lot of modification on those index, and it spent us a huge amount of time, and also to maintain all the vector index have the same functionality. So one day, after release that we find that we are not aligning certain features that like this didn't support the filtering features. So we got really struggled, and we began to build our own index for Zilliz Cloud to support various vector data types, and also various data types like flow32, like BF16, like FP16, binary vectors. We want to build a vector index that support different index types, like both graph-based index and also AVF like inverted file index. We want to build an index with different quantization algorithms, SQ, PQ, with different storage, like in memory, on disk, even remote storage like S3. We want to build a vector index with GPU support. So we did a lot of refactoring on the new index, make sure that every part of the index is pluggable, and that is the beginning story of this Cardinal.
Great. Then can we talk about, from the customer's perspective, what are some of the good use cases for Cardinal? I understand it's not only about speed, it's also about efficiency. Do you mind talk about that more? Maybe I can show the architecture. We can talk about just like align with the architecture.
Sure. So as I just said, so Cardinal is actually very, very pluggable. If you took at the architecture, right, we have pluggable quantizers, you have pluggable distance calculators. You can have cosine metrics. You can have L2 metrics. You can have different kind of customized metrics as well. So it also split all the major part of a index. We have a pluggable index builder, which means you can build all kinds of different index. We can have AVF index. We can also have different searchers. You can use different algorithms to search on the same graph. Yeah. So since it's going to be very, very flexible, and the interesting part is you can do a lot of different combinations. For example, H&W index, they don't have any quantizations, right? But the FAST probably has the most powerful quantizations algorithm. So after we combine them all together, it allows us to do quantization on graph index. Yeah. On the other side, since we have all kind of indentations, we can dynamically choose between using a graph index or using an inverted index based on a lot of query conditions. If the top key is very, very large, then maybe use graph indexing not very efficient, so we pick AVF index. If the top key is very small, then definitely choose graph index. Yeah, and you can also implement different compression algorithms. We can automatically pick index building parameters. There is actually a powerful tool, we call it as auto index. So it helps you to tune all the parameters without adding like a specific knowledge from your side. It just did all the knob tuning work for you. Yeah. And thanks to all those optimizations, with this release, our high performance tier has achieved the performance improvement of more than 10 times compared to the open source solution what we have for Milvus. And the most exciting part is also it reduced 50% of our memory usage. So which means for each 1 CU performance instance, originally it can only store 1,768 dimensional data, but now it can support 1.2 million vectors in 1 CU. Yeah, and on the other side, for our disk index, with this Cardinal, we also achieved the 50% performance improvement compared to our first generation of Zilliz Cloud index. Yeah, and moreover, Cardinal has extensive optimization for scalar filterings. Yeah, so Milvus is actually the first vector database introduced pre-filtering, which has almost become a standard feature in all vector databases. Yeah, building on the basis of pre-filtering, we implement a lot of optimizations in Cardinal especially for the connectivity for the graph index. And we also have a specified optimizer select a different filtering algorithm based on different data cardinalities, different query conditions, and this leads to a strong filtering performance improvement. Yeah. So if you want to know more details about performance, maybe you want to try it by yourself, we actually have an open source library called VectorDB Bench. So we have a bunch of test cases. You can run these test cases among of the mainstream vector DBs, compare their performance. Stephanie.
Yeah, it's very exciting to hear that the journey continues. We're continuing to build better things on top of Cardinal to benefit all our customers. Then let's move to the role-based access control. I did a little bit of research myself, and I realized Zilliz Cloud role-based access control is the most advanced compared to any other vector database vendor on the market. We have the 4 rows on the control plane and another 4 rows on the data plane. So James, I just really want to hear from you why the team think this is a very important thing to build, since I think we probably spent the past 3-4 months and to just like build a bit by bit to have such a granular RBAC.
Yeah, I mean, as the data security and being enterprise ready is our first priority. So this applies not only to our cloud service, but also for all the open source users. For all the open source users, we also recommend them to enabling TLS, user authentication, and also RBAC. Yeah. For our cloud, I think it's, we also spend a lot of time working on all the enterprise ready features, all the complaints, all the data security features. Although I know for many of the AIGC developers, currently they might prioritize to getting their logic to work. Yeah, but I mean, data security is still going to be a primary concern. Yeah, this is especially true when your vector data can potentially be reverse engineered to recreate some sensitive or original informations. Yeah, further amplify your risk of your data. So RBAC is going to be one of the key features of our data security. So this cloud supported roles such as admin, read-write, and also read-only. Yeah, it helps us to management all the internal users via enterprise admin. Yeah, and furthermore, we plan to introduce LDAP authorization and also customized role features for our enterprise tier. So for on our next major release. So stay tuned. For those who has security requirements, and you should also look at our BYOC. This release allows you to store all your data in your own VPC, with Zilliz only deploying our control point in our VPC. So this approach maximize your security of your data, ensure that all the data remains in your control, and this is under the most strict privacy protections.
Yes, we're gonna announce the BYOC bring your own cloud soon, so stay tuned. Lastly, let's talk about the Databricks Spark connectors. James, do you want to just share your screen? Let me stop sharing first.
Sure. So let me quickly introduce the Spark connector. Yeah, we actually provide seamless integration between Spark and Milvus, combining all the data processing and ML features of Spark with all the vectors, data storage, and search compatibility of Milvus. The integration actually enables various interesting applications. For example, efficiently bucking their data into Milvus, move data between multiple Milvus or like some other storage. Yeah, analyze the data in Milvus with leveraging Spark and Leap. So I can give a quick demo of what Spark Connector can do. One moment. So what if you are a developer and you try to search on all your structured data? So without this Smart connector, what you have to do is, first of all, you have to run a Spark job. The Spark job, what they did is read out your unstructured data, doing pre-processing, put all the data into an embedding model, and then after embedding, you just store all the data into another storage. Usually it's going to be S3 or your local storage. So from there, then what you have to do is you have to write some glue code, put all the data and push them to a vector database. And user can run a search on the vector DB. With our new Spark connector, things become much easier. So Spark directly can run some Milvus utility functions that will directly put your data into either open source Milvus as well as your Zilliz Cloud with very simple code. Yeah. So I'm just going to give you a very quick demo about how we can run a Spark connector. Yeah. So what I'm trying to do is trying to dump some data into MySQL cluster and migrate all the data into Milvus. So the first stage, there's nothing special. I do a Spark client, try to write some data into a data frame, right? And second stage, I read the data frame into a MySQL, and read them out as another data frame. Okay, and the critical part is here. So with just maybe 20 lines of code, you're going to be able to run the embedding of all the data and put into Milvus. Yeah. So first of all, you decide what kind of tokenizers you're going to use, and then the tokenizer will transform the original MySQL data frame. So next step is you're going to specify your embedding models. So now what we're using is a word to vector, and tokens is our input, and our output is actually a 128 dimensional vectors. So after this transform, right, you get another data frame with all your embeddings. Yeah, and the last step is to load this Milvus data frame. So in this data frame, you have to specify some of the key params, like what is a Milvus host, what is a Milvus port, what kind of collections you're going to load, what is actually the vector field name, vector dimensions, primary key field of this Milvus collection, and then you do a save. Then what happens is Spark will going to pull all the data out of MySQL and do embedding, put all those embedding data into Milvus. Yeah, with these functionalities, it's not going to be only work with Spark, open source Spark. You can, if you are a Databricks user also, you may have a lot of Upsert data in their platform, and we also announced integration with Databricks. So with just 10 lines of code, you can pull all of your data from Databricks, do all the embeddings and analysis to find all the insight for your Upsert data. And what's more, with the Databricks connectors, you can do a lot of analysis on your vector data. For example, if you can do distributed clustering with Spark ML Libs, or if you have found your anomaly data, vector data, yeah, Spark can help you to do a lot of distributed computations, while Milvus can help you to be a scalable storage. So both Milvus and Spark are going to be work together very closely, as well as our Zilliz Cloud and Databricks. Stephanie.
That's awesome. And we have, James, my understanding is like we have published this code as well as the notebook, Jupyter notebook on the website. So anyone who's interested can check. We can send you the link in the email as well. So if you want to check. Then before we close, James, just like curious, you already talked about some of the exciting things on Cardinal and the security front in the future. But how are you gonna envision Zilliz Cloud in the next 6 to 12 months? What are some of the exciting things that will happen?
So I think I think the first priority is going to be reduce the cost. So we aim to significantly reduce the cost of vector data storage in the next 12 months, targeting 2 to 3-fold decrease. Yeah, with the continuous growth of AIGC applications, I think there will be an explosive increase in the volume of vector data by this year. So cost is going to be very, very critical for all the Zilliz Cloud users, as well as all the AIGC application developers. Yeah. And secondly, we are working on Zilliz Cloud service. So in response to the evolving needs of the RAG applications. Yeah. They have all the similar requirements, right? Multi-tenancy. There are a lot of hot data, but there are also like a lot of warm tenants and cold tenants. So how we can separate all the data? They want elasticity because their application is growing very, very fast. So we decided to release our new service tiers. So this tier will be designed for offering fully on-demand billing for both queries and storage. So accommodating all the need for RAG application designers with millions of tenants. Yeah, we also have automatic scaling capabilities. Make sure that it can adjust your resources needed for your workload. Yeah, and third, I will say to optimize the search quality. So in all the RAG applications, search quality is actually very, very critical. So Zilliz Cloud is set to introduce features such as sparse embeddings, such as heavy search between sparse and dense embeddings, and query rankings. So those can help users to find more accurate results. Yeah. The last one I would say is actually integration and easy of use. We have launched this called pipeline, so designed to assist users in performing a series of operations such as data chunking, embedding, search, and ranking. Yeah, so to facilitate true data in, data out, we're gonna to support more features in this called pipeline, including like multimodal search, including more user-defined functions. Yeah, so moving forward, this called pipeline will be working together with a lot of open source projects as well as the other SaaS projects, achieving a seamlessly data integration between Zilliz Cloud and other data providers.
So very exciting news. Please just stay tuned. We'll definitely keep you updated whenever there's such a new exciting feature get out. That's all the question on my end. Is there any questions from our audience? You can just like place your question in the Q&A box. So James can try to answer your question. Let's give a few minutes and to see if anyone wants to raise hand. Okay, there's a question. How is Zilliz comparing to other managed solutions like Pinecone or VV8? Oh, that's a good one.
Yeah, that's a good one. Yeah, and that's also my favorite ones. Yeah, so I'm not sure like which part of comparison you're looking for. I can give you some general ideas. First of all, like we have open source project Milvus, and it has been running for quite a while. So for those cloud, we build down fully on the open source solution. So for sure, there is no window locking, right? And also, since you're asking for performance and cost, so the easiest way to do that is you can directly running our VectorDB bench. So it has performance comparison for both Pinecone, for Vivid, Cauldron, and some other like major VectorDBs. So from our test result, I'm not saying that it's going to be a fair comparison because it's the data is from our benchmark. Yeah, currently we are actually much faster than all the competitors. So, and also since we offers disk solutions, the capacity tiers, so we are not put all the data into main memory, but on the other side we put most of the data on the disk. So it also greatly save our memory cost. So if you are building some AITC replications and you are not looking for very fast performance, I would say that the capacity optimizing instance can help you to save a lot of money.
Awesome. I also put the link of a VectorDB bench in the chat, so feel free to check for yourself. Let's see if there's any other questions over there. We'll give 2 more minutes.
Yeah, and one thing I want to mention is also about enterprise ready. So that will also be a big difference because when we talk about VectorDB, right, it's not every vector database is actually a database. So when we mention database, what we expect is going to be it has a lot of management tools, it has visualizations, it helps it has data backups, have migrations, have further recovery, those kind of stuff. So when you pick VectorDB, I saw those are like very important evaluation you have to do, right? And also functionalities. What kind of features can we support? I think where every vector database may have filtering search, may have meta filterings, but the performance is going to be very different. Yeah, so you have to test a lot about all the functionalities as well as some enterprise features. That's going to be very important.
Yep. It seems we don't have more questions in the chat. With that, I just really want to say thanks, James, to be here, try to share with us the whole audience, like what about the new features in Zilliz Cloud. And we look forward to our next launch. Thank you.
All right.
Bye, everyone.
See you guys.